So I'm going to be talking about this product called Open-appsec. It's an open source product that helps with your web application firewall, or just in general your web apps, and providing protection against things like zero-day attacks. And the kind of where this open source app comes from is a company called Checkpoint, who provided all the food and drinks for tonight's event. So thank you, Checkpoint. And so we're happy to talk about these folks. So getting into it, I want to first present the problem that exists with most other web application firewalls. I'm just going to call it WAF from now on because it's easier to say. So WAFs operate in a manner that deals with signatures, right? So every time you are aware of a certain vulnerability, that vulnerability is made public or what have you, you have to add that signature to your firewall in order for your request to get blocked and for your application to stay secure. So the timeline looks something like this. So the vulnerability exists, hasn't been made public yet, and you remain vulnerable for however amount of time until the vulnerability is published, usually in CVE or a common vulnerability database, and then you can make your way towards creating that signature and adding it to your firewall. Not until the signature is deployed is when your application is actually secured and preventing that vulnerability from occurring in your environment, which is quite a long time, or could be a long time. In the case of the yeah, exactly. In the case of Log4j, this was like some companies were left unprotected for years. So there's really a big window for your applications to be existing as vulnerable. So many WAF solutions are based on static signatures, like I just said. So after the attack has been published, so who knows when that exploit was actually out there and found, and attackers were able to take advantage of that exploit. So it's never really able to protect against zero-day attacks. And that's really the solution. What this solution really solves is protection against those zero-day attacks. So this creates a wide vulnerability window, like I just described. So you have all this time between your app being unprotected, and then the signature comes out. You're able to implement that signature and then protect yourself against that vulnerability. Also, with common WAF solutions, there's these false negatives that occur. So your app is sometimes protecting against too many vulnerabilities, and sometimes letting things slip through the cracks and letting those vulnerabilities sneak into your environment. So the false negatives pose a security risk, obviously, because that vulnerability is you're being attacked in a certain way, and so that could cause data loss, service interruptions, whatever that means for your application or for your business. And then false positives can block customer access and impact your business reputation. So you have a false positive, your customer is denied entry into your web app or whatever visitor, and that impacts the availability of the application. And as we know, there's not only the vulnerabilities themselves, but there's also common mutations of those vulnerabilities. There's lots of different versions of the same common vulnerability that we all know. So keeping up with that and constantly creating these new signatures is really exhausting for admins like myself, especially. So what this application, this open source application, aims to solve is not having to rely on these signatures. My logo of Open-appsec disappeared. I'm not sure why. I'm sorry about that. But that's supposed to say Open-appsec, which is more or less an agent for your ingress resource inside of your Kubernetes cluster. So like I said, there's no reliance on this signature-based model, for the lack of a better word, and we use a ML tool, machine learning algorithm, and data set to evaluate the possibility of this being a vulnerability that you need to be aware of and that you need to block, and it's very much automated in that sense. So, like I said, signatureless, doesn't rely on a lot of signatures, on a list of signatures rather, and acts on autopilot for API protection. So we're going to go through a little bit of a demo here. If you have your laptops, you can follow along, or you can just watch as we go through the steps on the screen as well. So we'll start by booting up this application that is by very nature vulnerable. So we'll perform a SQL injection attack on this application. We'll deploy Open-appsec to try to protect ourselves against cross-site scripting or whatever attacks there may be, SQL injection, and then we'll attack the application again to see that the protection is effective. Hopefully we get blocked, and then if we have time, we'll connect to the SaaS solution that Open-appsec provides. So we're kind of putting on our hacker hat now, and we'll go and try to hack this app running in Kubernetes. So this is available, by the way, if you want to do this on your own at home or some other time. Just go to Open-appsec.io and click on Playground. All right, so let's wait for our environment to boot up. Shouldn't be too long. So now, if we hold on. Increase here. Can you see that? All right, so you can see now that we have so this is on the Open-appsec.io website, and it's so Playground, and then it's the Kubernetes ingress Playground. All right, so we have our this Nginx ingress controllers deployed. It's a pretty basic deployment, so we can see that we have our pods that represent this controller in the ingress namespace. And there's our controller running, and then we have a web app namespace. We have this vulnerable app called Acme Audit. And so what we're going to do now is we see that it's not only a deployment, but we have a service, and we also have an ingress resource. So this is broadcasting on the web, and so we're going to access it just by clicking on the click on this link here, which will bring us to the web version, or the. All right, so I'm putting on my I'm putting on my hacker hat. So I'm gonna try to access this application by giving it a SQL injection of some sort, and then I'm going to make up a password, pass, and then I realize that I have accessed this application and I'm seeing a consolidated statement of income. So this is not good, right? So we're simulating gaining entry injection to this application. Now we're going to go through and try to fix that. That doesn't happen again. All right, so Open-appsec itself is pretty easy to install. Use this command to grab the binary and to executable. Then we'll run it, and then it'll go through the CLI, which will walk us through the installation. So it automatically detects that we do have an ingress resource. It asks us if we want to use that ingress resource existing, or do we want to create a new one. We'll use the existing resource, and it has detected that the ingress controller is in the, ingress is in the web app namespace. Use that. Again, more or less think of like an agent or kind of a sidecar situation there where we're using ingress and installing some CRDs, which we'll look at in a second, to implement certain policies that are associated with that ingress resource. There is a help chart, but we're installing it through the CLI instead. So we'll just take the defaults here in terms of now what we're doing is we're creating a YAML manifest to create the Kubernetes resources and those CRDs that I just mentioned. Ignore the email prompt there. And now it prompts me to apply these not only to the existing ingress resource, but also to implement these Open-appsec policies. Policy, kind of like a network policy, but it's one of these CRDs that Open-appsec is installing in the cluster. No. So this is a
library that's going to be
exactly. Yeah, this is all provided, and I'll talk about that in a second. I have another slide on that. Okay, cool. So now that we've deployed Open-appsec, and if you want to take a look at the CRDs. So we have these CRDs: custom responses, exceptions, log trigger, policies, practices, source identifiers, and trusted sources. All installed as a part of that CLI prompt that we just went through. You can see the policies by listing them here. Best practice policies. These are all kind of like generic. There are options that you can choose in that CLI to kind of tighten it down more, or be less restrictive in terms of some policies that are enforced. But we're just taking the default for demonstration. And then we're looking at the policy, and then looking at the practice as well. Those CRDs that were okay, now that we've done that, we can move on and see if our app is now protected. We'll try that SQL injection again.
It's going to run side by side.
Yeah. Yep, so it's running inside of your Kubernetes cluster, and it's installing these CRDs, implementing these policies, and then modifying your existing ingress resource. All right, so let's try this again. hopefully, let me try to break into this app again. That's exactly what we expected. So we get a denied message, and now we're not able to view that application and exploit that app. All right, so yeah, so there is certain logging capabilities with this as well. So in addition to your standard, logs and so. All right, so yeah, so very timely. So yeah, you can run kubectl logs in the Open-app namespace, Open-appsec namespace. Namespace that got created.
Identified as an SQL.
Right. Yeah. So running this command here. So taking a look at those practices that we just implemented. There it is. Security action prevent and the practices here. In the logs. So there you go. There's your logs. All right, so going back to the slides for a second, I'm sure you're wondering how this all works. So let me fill you in on that. So the machine learning based enforcement engine, sorry, let me rewind. So there's basically two stages in which the request goes through. The request of the app, that is. Usually it's a HTTP request. Stage one is the first kind of line of defense, so to speak. The machine learning based enforcement engine looks for attack indicators within the HTTP request. So this is the kind of machine learning model that's been built to kind of millions of malicious and benign requests to identify indicators. So there's this model that's been built over time using millions of kind of use cases and practical examples of how to kind of evaluate these requests. And then stage two, if a request has been marked suspicious, it then carries on to stage two, which is a further evaluation of that request. So the request is further analyzed in the contextual machine learning evaluation engine. And if you're wondering what that is, it just provides additional context like application structure, how the user in general or individually interacts with the content, and more. And then the evaluation is done also in an online non-supervised ML model, which is built and updated continuously in real time. And that's the Open-appsec model. Yeah, so this is primarily for web apps. So this
that might be. I can probably being updated. I guess I can get a version on my app.
Right. Yeah, you can pull down updates and update the kind of Open-appsec engine. Yeah, on occasion or on schedule or whatever the case may be. Yeah. So
you run against any the model had to be trained, so able to identify the traffic set up block it, or you always having to your day comes out, are you always having to retrain?
No, actually, it's the former. So a lot of zero-day attacks we're able to defend against and block because of the machine learning algorithm and the way that it detects some of these common anomalies. So that's really the use case here is for zero-day attacks, being that you don't have to update those signatures like I mentioned before, and any kind of manual intervention there. The most touted, I guess you could say, example is they have this white paper that you can download also at Open-appsec.io that goes through some common examples, real-world examples, like the log4j, and just how that was evaluated and blocked long before the signatures were created and or the vulnerability was detected. And so that's kind of their, I guess, golden use case or case study for using something like this. And so it goes through, and not only how it protected against log4j, but also going through some of the what the exploit string looked like and how it was evaluated in the end, and how it was scored. Because as I'll get to in a second. Yeah, so it's all in-house. So it's all in-house. It's trained. It's fed millions of different previous vulnerabilities and previous kind of user interactions, common patterns that we've seen in the past. It's
I'm trying to understand that there is a new attack.
Right. I mean, yeah, it is reactive. Can't tell the future. Can't predict the future. But yeah, what we're trying to do here is essentially find the commonalities. Being that machine learning is really trying to find patterns, finding those patterns and connecting them to try to kind of forecast.
That's the general one.
Yeah, exactly.
Attack.
Yeah. Exactly.
So when something like that comes up, it's like pretty sure this is sus. I'm not allowing it through, but I can't say it's objection. I can't say it's credit stuffing or something like that. It looks like this just looks bad. Like I'm not going to allow it. Yeah, it's just
exactly. Yeah. So as I was going to get to, these are some examples of payloads and this score that's given by this machine learning engine. And so it evaluates it based on different characteristics, but these are some common ones that give it a higher score being the more potential to be blocked. And so the engine can accumulate all of these this history and these previous events, and then again trying to forecast those future events, develop this scoring system, and then based on that score, allow or block.
Set a threshold.
Right. There is certain kind of overrideability, so to speak. So there you can be more restrictive or less restrictive. But all in all, this is the machine learning model is doing all the training. It's preventing you from having to really take any.
Yeah, but as an Australian, we a credit that has US dollars on it, but the Australians doing it. Trying to United Airlines in US dollars. That's suspicious. Does it account for well-known CIDRs that are that is that part of the weighting at all? Or IP addresses or actors and things like that? The concept there is just
so it's primarily HTTP requests, so over the web. Yeah. And yeah, for more, including that case study, which goes into more depth about the how things are scored, more detail about how the model is trained, and more information about Open-appsec itself and how you can install it for free today. And your hands dirty, go to open-appsec.io. And again, my name is Chad. Here's my socials, and I also have this community of about 400 people now, Cube Skills, to learn container. Encourage you to join and on the fun learning new. So thank you.